So let's continue to the eccentric gusset plate connection, which are the most critical connections that you can solve actually from the sense of the gusset plate. So the analytical model that is hidden behind is comprised uh, from the gusset plate that is basically bolted and partially, or not partially, but welded to the tube, and also welded to the bottom plate. Um, as you can see, the collapse mechanism, as is written here, is coming or is composed from the plastic hinges at the gusset plate and the connecting plate. So that is very important to know that the trend and the dependency from the resistance perspective, that the resistance of such a failure mode is linearly dependent on the steel yield strength. So once you are increasing the strength, so that's going linearly, the bearing capacity, and actually the length of the plastic hinge. Um, Free length of connecting a gusset plate and quadratically on the thickness of the gusset plate and the connecting plate. So once you are changing the thickness, that's going not linearly but quadratically the bearing resistance. So actually the CBFEM model that has been utilized is set as a NVYZ. So that has been how it was like I'm mentioned behind or before, that the bending moments actually at the end of the supercondensed element that is invisible are equal to 0. So this is like a prescribed um, rotation. So the applied forces are in the position of the center of the bolt. So what we will elaborate more in the figure 5. And actually, this is the most important sentence that I think that is coming from this research. Let me to highlight it. This one, that in the ideastica connection, there is basically no, you are not able to imply the eccentricity and the second order effects once you are using material nonlinear analysis. So the member is loaded by the normal force to simulate the bending moment of the gusset plate and the connected plate. The eccentricities and the second order effects are basically replicated or are substituted by the shear force that you need to additionally insert, that is equal to normal force divided by 10. How does it work in the practice? So actually, let's imagine that you have a connection like that, and your forces is coming from the node to the end of the condensed element, and actually it causes the primary bending moment, because that's going to this part. This part has some eccentricity um, uh, versus this gusset plate. So actually, it's starting to deflect, okay, because you are just decompressing the member. So there, it's leading to like a primary deflection and rotation. But actually, to impose the second order effects and imperfections that you are not able to accommodate in the ideastica connection, you will apply basically the force here in the shear. And what does it cause? It causes like additional bending moments that represents basically the imperfections and secondary bending moments. So it basically leads um, to the fact that you're able in the ideastica connection um, to model also the, I would say, the portion of the imperfections and also the second order effect once you are using material nonlinear analysis. So here is also the verification and the validation that where the results and also the equation that has been described above is coming from. So actually, and this is also compared with the other like commercial tools on the same level as Abacus and also ROFEM DIC. Okay, so once I'm just coming back to to the models, as you can see, there have been also considered like a different number of the bolts on the connection, and actually here are the results. So the blue color that is represented in the experiment, those are the values that are the essential one because they are coming from the experiment, and we can compare our numerical solution within those values. So for us, it's very important the CBFEM. So you can see I'm always under this value. There is just one value that is like exceeding, and this is for the specimen D1. Otherwise, all the other values are coming lower. Okay. So once I will check the sensitivity analysis because there is very important to check what is happening if you change some parameters that are basically behind. So this free length, once the tube is connected, actually, so you can see once the free length here is increasing, so also the bearing capacity is basically decreasing. Okay, so once we're increasing and the trend looks more like uh, quadratic quadratic function, I would say. Yeah, so once you're increasing the length in between the welded part of the tube and this gusset plate, so you are just reaching the lower axial lower resistance of the collection in general. So, and hey, here is written that resistance is linearly dependent on the free length. So maybe this graph is a little bit misleading from this point of view, but here is written it's linearly dependent. Actually, once I'm just coming to thickness sensitivity analysis, you can observe that for thickness, it's like a different story because for if you are increasing thickness of the plate, so the trend is quadratic. So it helps when you want to increase the bearing capacity, you rather to change the thickness and you will receive immediately higher bearing capacity. What about the distribution of the bolts? So actually, if we are approaching and discussing the number of the bolts in the connection, so we can say that the load resistance is the load resistance is basically not changing at all. Yeah, once you are changing the number of the bolts. So for number of the bolt 4 is like equal axial force resistance as for number of the bolts that is equal to like a two rows of the pair of the bolts. So actually, once I'm just approaching to the yield strength, what can be as another parameter, so we can observe. So based on the CBFEM, that is this part, we can see that the trend is coming to be linear once you are increasing the yield strength of the material. So we are approaching to final conclusion and final recommendation for idea statica connection and eccentrically gusset plates. So recommendation for pinned members connected by unsymmetrical gusset plate connection. Again, keep free length of gusset plate and connecting plate as short as possible. So this is the part that is basically discussed at this section. Once we are heading to model type, again, stay by the NVY reset and restrain all the rotation. To evoke some imperfections, eccentricities, and second order effect, use the recommendation use the recommendation that is equal that to your current force, to your current shear force, you will add to another shear force that will be applied to the center of the bolts and is equal by normal force divided by 10, what is like a 10% of the normal force, and calculate stress and strain. And I would like emphasize you, for example, to calculate also the buckling, just for to be sure. Okay, so this is just the recommendation that are coming from the rigorous, I would say, verification that are coming from the steering people from the industry. This is coming from the university in the Czech Republic, and a lot of like a steering committee members has been included. So I do believe it will help you to more trust in the solution of the idea statica from the sense what model type should be used for eccentric cassette plate. So thank you so much and have a nice day.